In the last section, we had a long discussion about how we're going to solve some big issues around our current caching setup. In this video, we're going to move on to writing a little bit of exploratory code to figure out exactly how we can first hook in to the exec function that is tied to every query that is issued by Mongoose. And we're also going to write some code to figure out how to generate a unique cache key that is based on the query that we're working with. The first thing we need to do here is understand some of the code inside of the Mongoose library itself. If we can understand how a query is actually created, we'll have a better idea of how we can actually hook in to the exec function itself and write and run our own custom caching code inside that. So I've taken the liberty of already opening up the Mongoose library on github.com. So this is the actual source code for the Mongoose library. We're going to take a look at the actual source code for queries that are created by Mongoose. And once we understand how that source code works, we'll have a better idea of how to hook in to that exec function. So inside this repository, I'm going to find the lib folder. This is where all the actual useful code inside of Mongoose sits. So I'm going to open up lib, and then inside of here, I'm going to find a file called query.js. Here it is right here. So as you might imagine, this has all the logic inside of Mongoose tied to writing, filtering, and issuing queries. Inside of here, I'm going to scroll down just a little bit. And as I scroll, unfortunately, this is kind of a laggy page for me, so it might take me just a second. All right, there we go. So around line 45 or so, you'll find a function called query. All of Mongoose is written using classical prototypal inheritance for setting up objects and classes inside the library. If you don't quite remember how prototypal inheritance works, remember it's basically how objects can inherit methods from other objects inside of JavaScript. So I've got a quick example to just give you a quick reminder of how this works. Okay, so we're looking at the function called query right now. That's what we refer to as a constructor function. Whenever we create a constructor function, we can use the new keyword on it, and that creates an instance of an object that is produced by that function. So if we say new query, that gives us back an instance of query. Now to add functions to that object that is created, we can assign them to the prototype property of the constructor function. So for example, if we want to make sure that every query that gets created has a function called find, we can assign it to query.prototype.find. Or for example, query.prototype.exec and prototype.limit. So then whenever we create a new query, they automatically get assigned that find, exec, and limit functions. So that's exactly how all the code inside of Mongoose is set up. It's using what we refer to as classical prototypal inheritance. All right, and so we can see a very good and simple example of that back inside of this query.js file. Here's our constructor function. This is what is called behind the scenes whenever you and I create a new query by saying something like, maybe for example, something like, well, here's a good example right here, blog.find1. So that's the same thing as directly calling new query, that query constructor function. Behind the scenes, that's what's actually getting called here. Okay, so now if we scroll down just a little bit, you'll see an example of where that prototype property comes into play to set up the inheritance stuff. So you can see right here, this is some very classic JavaScript code for setting up prototypal inheritance. And if you scroll down just a little bit more, you'll see where that prototype is used to assign a new function. It's like here's query.prototype2 constructor. And we can see an example of that if we say do a search on this page for .find as well. So query.prototype.find. Again, this is some kind of like more basic JavaScript stuff, and my goal right now is to just give you a better idea of how a query is created by Mongoose itself. Now the function that you and I actually care about is the exec function. That's the function that we want to somehow hook into or somehow override and add in our own custom caching logic. So on this page, I'm going to do a search for query.prototype.exec. And here we are around line 2934, so quite a large file. So this is the function that eventually gets called to actually run one of our queries. So you and I want to figure out some way to overwrite this function or add in some additional logic to it to make sure that we also check to see if a cache exists or an entry in our cache exists before sending this query off to MongoDB. Now the most important thing to recognize about this function is that it expects us to always return a promise. That's how we get some level of chaining from this thing. That's how we can actually wait for the query to be completed before trying to access the information that it actually retrieved. So eventually, no matter what we do, no matter whether we are actually running the real exec function or trying to access our cache or whatever, we need to make sure that we always return a promise, okay? Okay, so I hope that part, at least is just a little bit clear where this function is defined. It's defined on query.prototype.exec. So you and I are now going to write a little bit of code that's going to try to hijack this function right here and try to run a little bit of custom logic whenever a query is issued. So I'm going to flip back over to my code editor. Now the first thing we have to do is figure out where to write this code. Where are we going to write some stuff to somehow monkey patch that library? Well, inside of our root project directory is a folder called services. The idea behind this services folder right here is to locate in one location any code that touches many different parts of our project. Right now, the services directory holds the passport.js file because that is holding all of our authentication logic, and authentication is used in many parts of our app. So I think that we're going to write all of our caching logic inside of a new file inside of services as well, because caching is a part of our application that's going to touch many different areas of our code base. So inside the services directory, I'm going to make a new file, and I'm going to call it cache.js, like so. Then inside of here, I'm going to require in the Mongoose library. So I'm going to say const mongoose equals require mongoose. All right, now this is the part where things are going to get just a little strange, okay? So now we're going to see why we just looked at that Mongoose source code. I want to get a reference to the existing default exec function that is defined on a Mongoose query. We're then going to overwrite that function and just figure out how we can manipulate or execute extra code whenever the query is executed. So I'm going to write const exec is mongoose.query.prototype.exec. So this right here stores a reference to the original exec function, like the untouched copy of it, the copy that is supposed to be executed anytime a query is executed. And then immediately underneath that, you and I are going to write a little bit of extra code that tries to overwrite this function and add in some additional logic. So I'm going to say mongoose.query.prototype.exec. I'm going to use my function keyword here. Now notice we're using the function keyword and not an arrow function. That's because an arrow function tries to mess around with the value of this inside the function, and in this case we don't want to do that. This is a function that's being assigned to the prototype property. So inside this function, if we were to write out this, it should reference the query that is being produced. Long story short, we want to use a function keyword here and not an arrow function. Okay, so now inside of here, I want to write just a tiny bit of code that's going to somehow run before any query is executed by Mongoose. So I'm going to write out console.log, I'm about to run a query. And then right after that, we're going to run the original exec function. Okay, so we're going to run the original function just so you get a good example of how this thing works. So I'm going to say return exec.apply this and arguments, like so. So this right here is the code that we would run to execute the original untouched pristine copy of exec that you and I have not messed around with. We use the apply function so that we can pass in automatically any arguments that are passed into exec as well. All right, so let's now require this cache file into our project, and then we should be able to refresh our page and see this console log appear. And that's basically going to be our proof that we have the ability to hook into and execute some extra logic before any exec is called. All right, so back inside of my index.js file, I'm just going to require in that caching logic. So about right underneath our existing services passport call, we'll do services/cache, like so. And then I think I forgot to save the actual cache file, so I'm going to save that one as well. Okay, so now I'm going to flip on over to my terminal and just make sure my server is still running. Looks like it is. And now I'm going to go refresh my application inside the browser. So back over here, I'll refresh the page. I'll then flip on over to my terminal, And notice how now we see that console log of I'm about to run a query twice. So presumably that is some queries that are fetching the current user or who knows what inside of our application. But the point here is that we now have the ability to inject some extra logic that will be executed before a query is actually sent off to MongoDB, which means we can somehow intercept that query, check to see if the query has already been fetched, and if it has, return the data from Redis as opposed to actually sending the query off to Mongo. Okay, so I know this video has been a little bit crazy. You might have never actually monkey patched a library like this right here before, but this is a perfect example of how it's done. So let's pause right here. We're going to come back to the next video, and we're going to start to add in some more logic to kind of divine information about the query that is being issued.